3, 2, 1, go. And we're live. This is Retraice segment number 105 for Tuesday, January 3rd, 2023, 10 p.m. Eastern, 7 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. And we're trying to learn to control computer. We're in day 3, chapter 3 of AIMA4e, Artificial Intelligence, a Modern Approach, the deep dive. Now, our deep dive isn't just going to be one day per chapter, but that's how we're starting. January is just going to be about reading the thing cover to cover to get a feel for what we're going to have to learn to implement. What's it all about, man? What's it all about? You might think I've already done this a lot, gone through the book, and I have, but also this is the deep dive. This is serious. We're doing an AI degree in 2023, and that means Q1 is year one, and that means the first third of year one, our year one is going to be divided into 3 semesters, January, February, March. So our first semester is on AIMA4e. Listen, chapter 3, solving problems by searching. It's great. I don't know. I love it. I just love it. But that's not what I'm going to talk about. Well, I'm going to talk about it partly. I'm also going to talk a little bit about chapter 2 because there's this thing that's just, I'm getting this feeling which is in the title. So let's go to the notes. Solve or be solved. You know, have you heard of Douglas Rushkoff? He's I don't know what his background is. He writes books on technology and society and stuff. I like his books. I like his book titles. Actually, I haven't read, I take that back. I like his talking. I haven't read any of his books because they just haven't risen to that level of my priority one. They're in priority queue, but the evaluation function anyway, whatever. Okay, so, but he has that one called Program or Be Programmed. I like the title of that book. And I haven't, I looked at the TLC and all that stuff. Anyway, solve or be solved kind of has something to do with that sentiment. I mean, like we talked yesterday, was it yesterday? About how, well, AIMA4e describes the task environment as being sort of the problem and the agent being the solution. First of all, let's talk about agents and environments. As we've mentioned, I guess this was yesterday, dividing the world up into the universe, up into agents and environments is sort of arbitrary. The purpose of doing so is to analyze systems. You can call just about any artifact an agent if you want to, but really it's only useful to do so if it helps you analyze a system. Whatever we mean by system, I think we should use some version of what Hamming gives us, but never mind that now. That's on page 38 of AIMA4e. The task environment is the problem. The agent is the solution. That's on page 42. Okay, these are important ideas. These are going to roll up into what we're talking about. Chapter 3 is like a vast array of tools and fairly recent, like 1960s to 1980s sort of stuff. There's been, there's constant improvements happening since then, but really the heyday of search in simple environments, more or less simple environments, which is what chapter 3 is about. It was like the 60s to the 80s. They're talking about search. They're talking about heuristic search or using, informed, doing search with some information about the problem domain and then automating the construction or the invention of heuristics. And in fact, when they talk about that on page 99, they ask the question, Russell Norvig, could we, after talking about heuristics a little bit, is there any way to sort of automate or make inventing of heuristics, good heuristics, a mechanical task? And then they talk about relaxation and pattern databases and landmarks and learning as methods of sort of more or less mechanically inventing heuristics. Mechanical advantage is sort of the term that gets that's sort of an alternative to, that's sort of a technical alternative to the term leverage in physics. So when you think about leverage, you should always, and just to keep it simple in your mind, like what is leverage? Don't think about the finance definition, even though it's a perfectly good definition. First, think about just levers, screws, pulleys. What are the other ones? Wedges. I mean, they're all sort of different manifestations of the same deep idea that I can't even, I've tried to simplify what leverage is, what mechanical advantage is, and I have not come up with anything yet. But I haven't worked on it recently. Maybe I should try again. And I've always thought that computers are like the ultimate. Whatever's powerful about computers is sort of the ultimate in leverage. Make it as small and as efficient the transfer of energy as possible, and that's what computers are. You get smaller, you get down to the atomic level, and it's the only thing we're doing is just pure electrons or pure voltages and blah, blah, blah. Anyway, I'm not going to go into that too much. But if we start, I'm not the one who uses mechanical to describe part of what they're doing in solving problems by searching in Chapter 3. They say it. Page 99. Let's go to the text. Oh, Jesus, should have had this open. I thought I needed to be ready for other things, and now I'm not ready. We have seen that both H1, misplaced tiles, and H2, Manhattan distance, are fairly good heuristics for the 8 puzzle, and that H2 is better. How might one have come up with H2? Heuristic number 2. Heuristic 2 is better than heuristic number 1. Is it possible for a computer to invent such a heuristic mechanically? And then that makes me think of mechanical advantage. Does it make you think of that? What advantage am I talking about? It's the advantage of these people who can solve problems by searching. It's almost their advantage. It could be their advantage. If they want it to be. These are the AI engineers. If they want to be in control, they can be, but they usually don't. I don't know if they want to. Everybody wants to be in control to some extent, but I don't think people have a healthy respect for power and how hard it is to not be overpowered or taken over by someone who understands power better than you do. It's not the technical elite. It's not the engineers who tend to end up on the top of large nation states or revolutionary movements. Although it can be them, but it's usually people who understand power. They've learned about it by like human power, like social power, the kind that we've talked about. Not the physical kind, although the physical kind is, I think, quite analogous, if not directly related. You could probably draw a straight line if you knew enough physics, biology, and chemistry, and sociology. Okay, so this mechanical, and everything that they're doing is mechanical in artificial intelligence. Everything is, the agents are computer agents, software-based agents running on computers. Computers are machines, arguably the universal machines. Machines are about leverage, physical leverage, etc. But the mechanical advantage that accrues to AI engineers, and that might not stay with them, that might be transferred to whomever or whichever group or whichever entity, because it doesn't have to be a person or a human group, I guess, assumes control or achieves control over AI engineers. The power that they have, the impression that I'm getting from the technical details of AIMA4e and the technical artificial intelligence generally, as opposed to popular culture AI, philosophical AI, the things that are not dealing directly with the math, the algorithms, the code. The mechanical advantage of these people is astounding. The advantage, let's say, take out the mechanical for a second. What are they able to do? Well, the way that I'm thinking about it right now is like, math solves problems, but artificial intelligence and computer science, which is, sort of the broader context of artificial intelligence, solves solving. You do math to solve a problem or a class of problems, but artificial intelligence and computer science are about solving the act of solving itself. It's not. It's just way more powerful than math. Machines come into play when you're looking at the history of math. Like math and machines are almost always, talking back and forth to each other. But the new machine is the computer, and it's being attached to every other machine, and the new discipline is computer science or artificial intelligence within computer science that takes math and takes takes the nature of problems and the nature of solutions and the nature of algorithms that can find solutions to problems, and sort of mathematicizes those things, and by relating them directly to machines in theory and in practice, particularly memory space and calculating or processing time, and so AICS is solving itself. You do math to solve a problem. You do AI to solving problems, and that's a huge difference in my mind. And so then it becomes sort of like Doug Rushkoff's, program or be programmed. It's like solve or be solved. We just said, the agent and the environment are arbitrary. So who's the agent and who's the environment? Well, it just depends on what system you're trying to understand and whether you're doing a good job understanding it. The task environment is the problem. The agent is the solution. Are you part of the task environment? Well, are you an AI engineer, or do you control AI engineers? If you are not an AI engineer and you do not control AI engineers, well, while you're sleeping, they're working on solving problems and solving itself. And solving problems in the technical sense, in a well-formed, precisely stated problem, there's a initial state and goal state, or set of goal states, and you have an agent that's going to go solve that environment. And if you're not controlling the agent and you're not the agent itself, you're part of the environment. Now, you might not be part of the relevant part of the environment yet, but how many agents are out there? How many human agents? But really, we're talking about the program agents that they control. It's billions of these things. Every time you write, if you're in AI, every time you write an agent program, there's another agent. Every time you copy it, every time you run it. I don't know if it seems profound to you, but the idea that, it goes back to the computer control game. Retraice is for outsiders. What's going on out there is computer control. The computer control game is player-oriented. Outsiders are not players, therefore we're learning to play. But this is the next piece of that puzzle. This idea that what is a player in the computer control game doing? What do they do? Players on the soccer field kick the ball. Players on the football field block and tackle, run the ball. Players in the computer control game change environments. They build agents that change environments, and those agents, their performance measure, which can be, outside the agent somehow, or inside the agent in the form of a utility function, which I didn't really talk about yesterday because I hadn't really clarified that, but it's in the notes. AI engineers are building and deploying agents to change environments. If you're not doing that, you're part of the environment that's going to be that's being changed. Or that could be changed. And it's just nuts how focusing on problem solving itself. It's not like the mathematicians didn't do this. They just sort of started to get into it. In my reading of the literature, the mathematicians really started to focus on problem solving itself. I don't know what I'm talking about. I take that back. But it seems to me like, right around the first half of the 20th century, right at the same time computers and AI were being invented. AI didn't come like a long time after computers were invented. It was like, a few years before the McCarthy conference, what was it, at Dartmouth? The first AI conference. It's like 55. Computers were invented, depending on where you want to start the clock, in like the 40s, around, because of World War II. Solve or be solved. You're either controlling agents, controlling people who can control agents, and trying to change the environment according to your own preferences, your own utility function, your own objectives, your own goal states, or you're part of the environments, the many environments of those who are changing environments. It's not like this is new in human history. It's just that the power of it, it's so mechanically advantaged. It's different now. Anyway, we keep going now. I just wanted to say that I think that might be what players in the computer control game are good at. And you don't have to be an AI engineer to be a player in the computer control game. You can be like Stalin or somebody who knows how to control people. Stalin, didn't have to know how to build anything or fix anything. He just needed to know how to control people, and then find the people that, by controlling them, would accrue to him the most mechanical advantage. Program or be programmed, solve or be solved, I think is bigger than that. Programming is different. Straight classic programming is different from AI programming. It's a different way of thinking. It's like, I'm going to tell the computer what to do. That's classic programming. But AI programming is like, I'm going to build an agent that goes out there and changes the environment. And only recently with like Russell Human Compatible and sort of AI safety has the community realized that the difference between our intended, objective put into the machine and the actual thing put, our intentions and our objectives put into the machines could be terrible. Like the difference could cause terrible consequences. But that's not even what I'm talking about right now. I'm just talking about, leave all that aside. Leave AI safety all aside. The power of this, the power of these machines, these techniques. They make whole classes of problems reducible to computing and code if you can put it in the right form and you can recognize that the problem has already been solved. Math was like this too, but math wasn't solving itself. Math was solving problems. All right, I've said enough. This has been Retraice segment 105. Same time tomorrow, 10 p.m. We'll do day 4, chapter 4 of AIMA4e. We're getting into complex environments. Now we've done simple environments in chapter 3. We'll get into complex environments. And we'll keep going with this thing. It's getting very interesting. It was always interesting though. But now it's like, never thought of it that way. Okay, that's it. Retraice.com, Retraice.com. Signing off.